Okay, good afternoon to all of you. I hope you are ready for the open lecture this afternoon. Um, so for your information, for those who just came in, this lecture is being recorded. So therefore, I hope that you don't make unnecessary noise. If there is any problem, mistake, or technical error, you may let me know. But if not, I don't want unnecessary noise because it's in the recording. The recorded video, if you're interested to know, to get it, you may get it from your lecture later lah, from your corresponding lecture group. In front there is some hard copy for the notes I ready for today's lesson. It's limited lah. I just printed 40 only. If let's say you get it lah. If you don't get it or if you don't feel like get it, then you may scan the QR code in the attendance list there. Then refer the soft copy. And make sure you sign attendance for my reference. If let's say the attendance list is full, you sign behind the paper. So far, I get only 2 attendance lists only lah. So if more than that, then please kindly sign behind the paper. Okay. So without further ado, I would like to go on further with our lecture here today regard on indices and surds. Okay, so go on. Okay, let's see. Indices. So when the time we talk about indices, you will see some terms or some number in these formations here, where this part here, the number at the bottom we call as the base, and then this upper corner here, the number here we call as the index, the power, or we call as the exponent, exponent. And how we read this term here is that, for example, we will read as a to the power of n. Let's say I have 3, then 2. So this is 3 to the power of 2. Just as simple as this. Then next, we go for the definitions. What you need to know about indices for the definition is that, first of all, if let's say you happens to have the number multiply itself for n time, we will just summarize, written it as a to the power of n, a to the power of n. For example, let's say for the case of 2 itself, it's actually 2 to the power 1, but usually the 1 here we don't write. If 2 multiply itself for 2 times, we have 2 to the power of 2. 2 multiply itself for 3 times, 2 to the power of 3. Just as simple as this for the definition. Then next, what if let's say we have the case that the power is turned out to become 0. So if 0, no matter what is the base number, if power of 0 is always equal to 1. For example, 2 power of 0 is 1, 3 power of 0 is also 1, 1000 power of 0 is also 1. The only one thing here we don't consider if power of 0 is this case here, 0 to power of 0. This one is not in our consideration. Okay, so continue. Next, the third definition we have here is that if let's say you somehow see that there is power of negative, a minus power there. What you mean by the negative power here is that we will happen to keep this term here, we put it at the denominator. So for example, as you can see from this example here, if I have 5 to the power of negative 3, then it actually means that I have 5 to the power of 3, we put at the denominator. That's it. When the time you put the terms at the denominator, the sign from negative, it will switch to positive. Of course, if let's say you consider, can I do something like this? 5 power of 3, can I make it to become 1 over 5 to the power of negative 3? Can or not? Yes, can, if necessary, according to the calculation. This is also correct. So the main idea here is as if like, when the time you switch the sign of the power, then the whole piece of thing, you change the position from top to denominator. Then next, the fourth definitions here, we're going to relate with power of fractions. And this one here is more on the next part on Surd, the connection with Surd. So, for example, if let's say I have 5 power of 1 over 2, this is actually referred to square root. If 5 to the power 1 over 3, this is square root of 5. 5 to the power 1 over 3, if it happen to be the case of cube root, 5, so on. Okay. Then go on. Just a very quick introduction before we go on to solve the questions. Then in here, we talk about some rules of indices. There's plenty of rules here, but in these notes here is limited. I just list out some of the things that we use very commonly. We use a lot. Of course, there is some other things that involve here, but I would like to refer on this few first. Okay. First of all, if let's say I have two number of the same base, as you can see here, I use the letter A there, same base, and they happen to be multiplied, then we can simplify the answer, turn out to become, the result is still the same base number, and then the power, we sum them up. Okay. These rules here, although in the notes you happen to see is that multiply and then plus power. But later in your calculations, these rules here, we're going to apply two ways. Maybe we're going to, from the right, we change to the left, or the other way around. We're going to apply two ways. Okay. Some of the example in number that we're going to see here, 7 power of 3 times 7 power of 2, it will be 7 power of 5. How we do that? Same base number 7, multiply, so we take the power sum up. 3 plus 2 equal to 5. That's it. And if we go for more complicated case, complicated case, base 2, power of x, power of 2x plus 1, multiply, so I will have, combine them into same base number, power, we sum them up. And this one I do slowly for the addition, and we can see the result is 3x plus 1. Similar idea when the time comes to divide. For divide, either we write in the form of division sign, or we write in the form of fraction like this. Then what will happen is that, again, we have the same base number AA, so we can summarize them into one single term as base number A, power of m divided by n. The upper one divided by the lower one, so we will have m minus n. And once again, we can see example here. 7 power of 5 divided by 7 square is actually equal to 7 to the power of 5 over 7 power of 2 equal to 7 power of 3. So in here, I just quickly go through the rules. I doesn't really spend time to explain to you by list out one by one. But if really you can't understand, then you come back to me later. I explain back in details to you. But now I just go through according to the formula of the rules first. Continue. The next one we use very often is number 3 here. When the time you have power. Previously, we just have power one time. Let's say A to power m, A to power n. But if let's say I have double layer power, for example, like this case here, the base number is 7 power of, the original number is 7 power of 3. Then this number, I further power it. Then how I get my answer? I will take the power, multiply. So 3 times 2 equal to 6. More complicated examples, and you can see bottom here. So 2 power of x plus 1, this is the power for base 2. And this whole thing here, we power further with 3. So the result, I will have the 3 multiplied with x plus 1. And as a result, we have 2 power of 3x plus 3. Okay. And for these rules here, sometimes we may apply it reversely. That means, just now, these two examples I show you is that I have power, and then I get the power multiplied. In some of the situations, maybe you need to apply it in the reverse process. You need to apply it in the reverse process. So one of the example we can see here is that maybe something like this case here, 8 power of x is actually referring to 2 power of 3 power of x. Wait, again, this is the case of power. Let's see. Can we possible to have some case that we do it reversely? Yes, we can. Let's say I reverse the process from here, from 2 to the power of 3. 2 to the power of 3x I reverse the process to change it become 2 power of 3 power of x, or maybe I can reverse the process to become 2 power of x power of 3. I reverse the process. And this idea here, somehow you may see it in some of the case in simplifications later. Next, for the case that if let's say I happen to have the two terms multiplied together and they being power. That means, for example, I have two numbers, A multiplied with B. And then this product, the whole thing, is being power further. And this result here is actually equivalent to A power of M multiplied with B power of M. As if like we expand the power inside to get the result. Example, you can see, originally for 6 to the power of 5, we realize that 6, we can return it as 2 times 3. So 2 times 3 power of 5, we can split them up to become 2 power of 5 times 3 power of 5. Then below, this is a similar thing like the case 4 here. It's just that the previous one is multiplied, this is divided. Okay. So these are all the rules here. I don't want to spend too much time on discussing the rules here, is because sometimes for hours discuss about the rules, but at last when time comes to questions, you still have problem that we cannot do. So let us try to see some questions there. Question number 1. So you do have the hard copy notes with the questions. The space reserved to you, I don't think is enough for you to have all the solution inside. So I hope that you have extra papers to jot down the solution accordingly to the questions. Okay. Go on. So let's see. Simplify indices expressions. So question 1, we want to simplify this term here. What is the idea of the word simplify? We want to make the things look simpler. We want to change the thing look simpler. Instead of 3 terms multiply and divide each other, can we simplify it to a much more simpler number in this calculation here? This is what we try to achieve in the calculations here. And let's see, how can we do so? So we have 2 power of n plus 2 divided by 8 power of n times 4 to the power of n. Okay, guys and girls, whenever you solve indices questions like this, the first thing I will always advise you to do is that first you identify where are your indices term. So these are the indices term that I have. I highlighted in blue. I hope that you can see I highlighted in blue. It's very light on the screen here. Then next, I want you to check, do all these indices term here, do I happen to have the same base number? So here I have base number 2, 8, and 4. 2, 8, and 4. Obviously not the same, not the same. If not the same, then we think about it. Can we make them to become the same base number? So of course it's possible here, where 2 is actually 2 power of 1, 8 is actually 2 to the power of 3, 4 is actually 2 to the power of 2. We can convert them to the same base number. Then, after we focus about the indices term that we have, next, let us try to see what are the operations that occur among them. What are the operations that we have among them, in between them? So we can see the operations we have is divide and multiply. If let's say the operation between them is divide and multiply, then you can refer to the rules to solve the questions. But if let's say the case is happen to be plus and minus, then the rules cannot apply directly. For example, let's say I have the case like this. 2 to the power of x plus 2 to the power of 2x. This one, I cannot say that I solve by 2 power of, so I sum up the power, x plus 2x, so power of 3x, because you see it's a plus, nonsense. It cannot solve like this. If a case of plus and minus, it may not able to solve like what you see in the rules previously. In fact, you check back the rules that we have. All the while in the rules that we have is that we have the rules about multiply, divide, or power. We don't have plus minus. Plus minus, some other story. And the hint I can give it to you is that plus minus, we consider about doing factorization to help us to solve. Okay. Anyway, back to this question here. We don't have any plus minus. We don't have any plus minus. We have divide and multiply. And how we solve this is that, okay, let's see the solution. First of all, I will copy back the whole expressions. exactly same as the question. I copy back the whole expressions. Then now, what I want to do is that since the operations is multiply and divide, for sure I can make use of the rules of indices. So I would like to change them to the same base. So in here, I would like to convert the 8 and also the 4 here to base 2. And as a result, what I have is that it will equal to the next line. The first term, 2 power of n plus 2. There's no changes happening. Copy back. Divide. Then 8 to the power of n, it will convert to become 2 power of 3 bracket power of n. Then for 4, it will multiply 2 power of 2 power of n. So this is what we see initially, where originally is, for example, 8 to the power of n. We change the 8 here to become 2 power of 3, then power. This is what happening here in the second line here. Continue. Make use of the rules that we have just learned just now, that you have a quick look just now. What rules that I'm going to apply now in this case here is that I'm going to apply this one, the third one in my list here. I'm going to expand the power for these two parts. So as a result, what I have now, the first term remain the same, copy back. Second terms, divide with 3 power of n, multiply 2 power of n. Okay. So this is the result that we have. After some time, maybe the second line, you may skip because you already somehow know lah. You can do express directly from first to third line is alright. So that's why this second line here, I purposely highlight in blue, just for beginner explanation. In the future, the blue line you can skip. If you want to write, no problem. But if you feel like writing too much, you want to skip, those typed in blue, you can skip. Go on. Reach up to here, guys and girls. What I have now is that I have all of them happen to be base 2, and between them, I have the operations of divide and multiply. So how are we going to solve it? So in this lesson here, let's say I solve it slowly as a beginner. I start to tackle this term here first. I simplify this part here. I highlighted in yellow first. So what I supposed to have is that I have 2 to the power of n plus 2. Divide 3n, that means I'm going to minus 3n. Then multiply with 2 power of 2n. Now, what have I done is that I'm applying the second rules for this part. Follow, when the time I have multiplied, I apply the first rule. I will get the result 2 power of n plus 2 minus 3n, and then minus 2n. So this whole thing here, multiply with 2 power 2n. So the power will sum up. Sorry, it's a plus here, plus 2n. So as a result, this is what we have. And of course, you can combine all this in once. You can combine all this in once. Then we simplify our answer. We got 2 power of 2, and this is equal to 4. This is how we get the answer. So from these examples here, we have applied these 3 rules to help us to solve the questions, to simplify the answer. So initially, it looks as complicated as this, but the actual fact that this is just actually equal to 4. So this is the idea of simplify. From a complicated form, we make it to a much simpler form. Go on. Question number 2. Just now we have the case that the base number is a number. The power is unknown. Now we refer to question number 2. The base number is unknown. The power is number. Okay. Then how we solve for these questions here? Okay. This one, maybe it looks a little bit difficult, but not too difficult. Okay. How should we tackle this question here? Once again, we try to observe what are the base number that we have here. We have x, we have y. Next, what is the operation between the x, y terms there? We find out that we have the operations, very obvious. The whole thing here is divide in fraction form. The x squared and the brackets here, we have the operation of multiply. And then these whole brackets here, we have the operations of power. So if evolve of the case of multiply, divide, and power, for sure we can try to make use of rules. Then it's up to your choice lah. You want to start with which rule first to solve the question, whichever that is suitable. So for today's solutions, what I will do is like this. First of all, I copy back the whole expressions. I start with the whole expression from the questions. Then next, I would like to tackle this part here that I highlighted in blue, where I would like to expand the power of 3 inside the bracket terms. Okay. How come? Okay, I would like to expand the power of 3 inside the brackets. And how I do so, I'm using this rules number 4 here. I'm using this rule number 4 here. So if you have the notes, you will see that I'm using this rules number 4 here. I expand the power into the bracket with 2 terms multiply each other. So as a result, what will happen is that the rest of the part maintain the same. So the x squared is still x squared, and then what happened to the bracket parts here is that I will have x minus 1 multiplied with x power minus 1, the minus 1 multiplied with 3. Sorry, not multiplied with 3, not yet. We just have x power minus 1 power of 3, and then y power of 2 power of 3. We expand the power first. We haven't multiplied yet. Of course, if you're advanced enough, you can directly apply multiply inside to get result. And this is also the reason why the typing here is in blue, because this is just for explanation for beginner. So we apply rules number 4. Follow? Next, what we want to do is that we still focus on this part here I highlighted in red. And now I want to go for rules number 3. I expand the power inside. I expand further the power inside. And the rest of the part maintain the same. The x squared and y power of 6 is the same. The changes on the part that I highlight, and I will have the result now, x power of negative 3, y power of 6. Then continue. Now, reach until this form here. By right, you should be able to see very clearly that we have all the terms with base x and base y multiply and divide each other. So by right, I can simplify them by using the rules. And by the time you simplify, I can work only among the same base. That means I can simplify among the x term itself. I can simplify among the y term itself only. The x and y doesn't cross over to simplify each other. So from here, as a result, what I will have now is that for the case of the x term, x squared multiply x power minus 3. So my multiply, we have power sum up together. Y power of 6 divided by y power of 6, I will have the result equals to y power of 6 minus 6. Okay. Of course, some of you may have the idea that why don't we just cancel this part you highlight in green, because 6 power of 6, 6 power of 6, just cancel. Yes, you can just cancel, but I just purposely want to show that we apply the rules of indices. Okay, go on. Continue. Simplify the answer. We have x power minus 1 times y power of 0. And what is y power of 0? Again, any number power of 0 except 0 itself, it always equal to 1. So in here, y power of 0 is 1. Then x power minus 1, what is it? So refer to the definition on top number 2 here. When the time I have power minus, I can switch the sign of the power, and then I put the whole thing at the denominator. In this case here, I have 1 over x. And therefore, your final answer, simplify further, is 1 over x. So therefore, this is the solution. Okay. The solution that present here today maybe is a bit long, but once again, just to explain step by step to you, whichever type in blue is those steps that you can skip in the future when the time you are advanced enough. So this is the answer that we have for these questions here, for simplify the expressions. Okay. I proceed. Huh? Okay. Next, I would like to go on with solve indices equation, where this is what we often see during exam, and it carry out I think quite high mark also. And the technique to solve it you find out that most of the time around the same thing. And in here, for today's lecture, I just want to focus on two major forms of indices equation. One is the basic case, where you can have indices equal to indices or some other terms, and then you solve using the simple way by compare both sides. The other one is by quadratic. Let's refer to question number 3. They ask us to solve this equation. Solve equation means that they want us to find out what is the value in this equation here when the time you do calculations. Okay, before I go on further, the example I give it to you is very simple here. You can just direct compare both sides and solve. However, if you realize the same questions actually is this one. I can modify it into something look a little bit complicated. Rather than you can just direct compare both sides like this, where you can see the same equation here, you can change it to other form at the side in the notes here. For example, the first one, I have the indices terms, I group it at one side. I group it in the same side. Or the second form here, the changes compared to this original question is that the left-hand side 5 to the power of 3, instead of having 5 to the power of 3, I have them split up. I just want you to have extra step to get this one first before you can compare both sides. Or maybe the last line, I totally expand the power. Power of 3 is become 1 to 5. Power of minus x become 5 over x at the bottom. I try to make the thing looks complicated, but actually it still come to something as simple as this in basic, if you know how to do the adjustment. Okay. And just for information, all these other form here, it cannot be compared both sides directly to solve the question, especially the first one. Because I believe the first one, some of you will say that you canonical compare both sides, and then you solve in this way here. And you can get answer. Okay, this is nonsense. Because compare both sides is, you compare left hand and right hand side of equal sign, provided they are compatible. In this case here, if you observe, the left hand side I highlighted in blue for each of this equation, and the right hand side I highlight in red on each of this equation. They are not compatible. Compatible must be happen to have the same form. They have something that's similar, and then we compare the different. But you look at the blue and red for each of this equation, they doesn't have similarity at all. So therefore, they cannot simply compare. Okay. Then back to our questions here. I use this simple example just for you to see the technique to solve. Before you can apply these techniques, what is the effort to make changes? That one, it depends on what you have in the questions. Like what I have other form at the other side. But actually, they are the same question as this one. Just that you need extra efforts to achieve this form before you can solve. Go on. So now, of course, you say we compare both sides, but why we can compare both sides? First of all, the left-hand side, which is the one I highlighted in blue, and the right-hand side that I highlighted in red, they must be in the form of same type and compatible. What you mean by same type? For example, if you're talking about indices, both of them must be indices. If one is indices, one is log, sorry, cannot be compared. If one is indices, one is surd, also cannot compare because not the same type. You must change them to the same type. Next, not only the same type, they must be compatible. Compatible in the sense of, like here, both of these is indices, and it is compatible because we can see that they have the similarity on the base number, but different at the power, and they happen to be equal to each other. So we compare the difference and then solve the question. So they must be compatible, where we can see there is some part they are similar. Then we compare the difference. So as a result, in this case here, we compare both sides for the power. We will have 3x from the left, 2 minus x from the right, and then we solve for the answer as follows. And please be aware one thing, please don't do cancel. It's not about cancellation. It's not about cancellation. It's compare. If you do cancellation, after some day you will think that, oh, I moved this one to the other side, so 5 divided by 5 cancel. It's not about this type of cancellation, please. is compare both sides. So I purposely make the remark and highlight here. We are comparing. We are not cancelling. So be aware of that. So this is some very basic questions for comparing both sides. If you refer to the lecture book, actually there is some example that is more complicated than this. But actually, once again, back to the idea. The original questions that is as simple as this, we can actually modify it to something like the other form here that looks complicated. And you need to have more effort before you can do compare both sides to solve. Continue. Next. Another form of equation that often come out in exam that you need to know, it's not difficult to solve, but you need to know. Solve such equation, and these equations here, if it's something to do with quadratic, again, the example I provide to you in this question here is a direct questions where without any hesitation, maybe you will just consider let, you will say that this is a let question. But why you can let? Under what condition you can let? Maybe you didn't consider, because this is the formation that you just need to consider about substitutions only. That's why you didn't realize that. Similar like just now, the same questions, I can do some modifications. For example, the first one, I just simply rearrange the terms. Instead of arrange everything nicely, everything on one side, 0 on the other side, I make it both sides have some terms there. Or this power part here, I make it to become some other power but equivalent. Then you will see the whole equation. We have different base for the indices term. One is base 4, one is base 2. Or maybe I can do something on the power. I don't change the arrangement, but I do something with the power. Where now the power, you will see that instead of just x itself, it turned out to become x plus 1. It may happen the same thing go for the case of power of 2x. The 2x may have plus or minus some number. We do something on it. But if you try to make adjustment according to rules, you will see that this question is also actually equal to my original questions here. Then the last one, where I think is the ultimate one, I try to mix around all this idea here in this form here, where I change the arrangement, I change the base, I happen to have something plus on the power. But once again, actually all these are the same equation. But I try to make it looks complicated, not so easy for you to solve. But of course, this example here is an example as simple as everything get ready. You just need to know that we solve by substitution, solve by quadratic equation. That's it. Okay. But once again, I want to remind you, not all the time you will get equation as simple as this, direct substitute, and then you solve. But you may need to have extra effort like the rest of the questions here. Okay. Go on. So how we start the question, as usual, we copy back the whole equations given. And as I said just now, this equation is ready to do substitution. Before we go further, I hope that you take notes how you can identify the case is quadratic. One of the way that you can identify is that after you're able to convert them into the same base number, the indices you're able to convert into the same base number, you try to observe the power. Usually you will see the power is 2 times of the other. One is 2 times of the other. For example here, power of 2x, power of x. 2x is 2 times of the others. Sometimes the question, they don't get 2x and x. They give 4x, 2x, 2 times of the other. 10x, 5x, 2 times of the other, also possible. But most of the time, they just give simple one, 2x and x, 2 times of the other. This is just one of the form. Maybe there is some other form as well. There's some other form as well. But this is one of the form, the basic one that I need you to identify. Then now, we do our substitutions. In here, I let y equals to 2 power of x. Then before I go on further for the substitution, some of you, after this, you may have these questions. How come this one can substitute one? By right, this is not about 2 power of x, this is 2 power of 2x. How come I can substitute? So maybe some of you claim that, hey, I need to have extra step. I need to show that this is actually 2 power of x, power of 2. Apply the rules of indices, power. power multiply, so power 2x. With this form, then only you substitute. But actually, you don't have to. As long as the x part here doesn't have any number plus or minus with the x, we can do the substitutions. So in here, I just need to make an extra remark. If I let y equals to 2 power of x, y squared is automatically equals to 2 power of 2x. Therefore, I can substitute the equations, and now I get the quadratic equations. For quadratic equations, until now in our syllabus, we still try to solve using the classic way. We're going to solve by factorizations, and then we have our answer, y equals to 4, y equals to 8. Then reach up to here, guys and girls, reach up to here. What we're going to do next is that don't end your answer here because you try to solve x, not y. X is the unknown in the question, y is the unknown that we create. So substitute back the y according to your substitution definition just now. Y is 2x, so we have 2 power of x equals to 4, 2 power of x equals to 8. And as a result, what we have next is that we try to see, now you back to the basic equations. Indices equal to 4. Can I happen to change to the same base is the first thing that should come into your mind. So base 2, base 4. Yes, I can change to the same base. So 4 is 2 power of 2. Now compare both sides for the power. Your answer equals to 2. Similar idea will happen on the side. We convert into base 2, which is 2 power of 3. Compare power. I have x equals to 3. There goes the answer. Go on. Before we go on with Surds, just for your informations, sometimes when the time you substitute until this line here, you may not be able to solve like what I showed you here. You may have some other situation. For example, you may have the situation that, let's say, example, not answer, example, if you meet this, what you do? Okay. 2 power of x, let's say equal to 1. So 2, 1. If I have 4, 8, 16, you know can change to base 2. If I have 1, can I change to base 2? So I can. And it's very easy to change whenever you see 1 because you just take the base number, power of 0, it will be 1. So in this case here, x equals to 0. Answer. What if, let's say, your 2 power of x is equal to fraction 1 over 2? Can I change to the same base number? So again, we can. This is actually equal to 2 power of minus 1. So x equals to negative 1. And negative 1 is the answer. Okay. Then refer to the remark at the side here. What if, let's say you have the situations, that, let me adjust back. Let's say you have the situation that the indices is equal to 0. Then this case here we will reject. Why we reject? Because a positive number, no matter how you power it, it will never turn into 0 because it is always positive. So if let's say you have the answer equal to 0, we reject it. We're not going to consider it at all to solve. There's no solution from here. Similar idea. If it's negative, also we reject because positive number will never ever turn to negative if you power it. So please be aware on that lah. This is the situation you may see in some other example. But today I have limited example to show you. So this is the only thing you can see lah. Go on. I would like to go on Surds. Okay. Surds in general, we write in this form here. The n here is trying to tell you the order of the surd. So the root that evolved in the surd. For example, let's say I have this one without any number. This is referred to the case of square root. This is the case of square root. If let's say I have some number there, for example, let's say I have 3 there, then this is the case that we call as cube root. So on and so forth. Let's say I have number 4 there, so this is called as the 4th root. If 5 there, 5th root, so on and so forth. However, in our syllabus here, we are just limited our discussions on square root. We just limited our discussion on square root. Everything we just discuss on square root most of the time, especially soft equation. Okay. Then one important thing to take notes, what is actually surd? Be aware so that you don't have misconception. Surd is not to say that you see there is this sign here, the root sign there, then you say that is a surd. You need to see the result of the number with this sign here, can it convert into integer or fraction or not? If it can convert into integer or fraction, then that is not a surd. For example, square root of 9 is not a surd because square root of 9 is 3. 3 is an integer. Square root of 1 over 4 is not a surd also because it can convert into fraction 1 over 2. So the idea of surd again, not refer to the root sign, but refer that the result after you have the root sign, can it change to a fraction or integer or not? If you can change to fraction or integer, like these two cases here, it is not a surd. Go on. For surd, we have some rules here. We have some rules here to refer. So the first rules you can see is about multiplications. If I have two roots of the same order, let's say square root. In here we discuss about square root only. Square root multiply square root, then what we can do is that we can put them under the same root, and the number inside the roots, we multiply them according to operation. However, be aware, this operation is only meant for multiply or divide. If let's say you have the case of plus or minus, for example, square root of A plus square root of B, you cannot say that this is equal to square root of A plus B. So these are not correct. Please be aware of that. Our rules here only apply for multiply or divide. If let's say we have plus minus, what you can only do is refer to 3 and 4 here. You must only do the operations plus and minus if they have the same surd. Then only you can do the operation. For example, I have 3 square root of 7 plus square root of 7. So square root of 7 only means that 1 square root of 7. So 3 plus 1, 4 square root of 7. If let's say, look at this square root, you felt that so confusing. Then for today's lesson, you try to understand in this thing here. What if let's say y is equal to square root of 7 in this case here? What happens is that here I will have 3y plus y. 3y plus y is 4y. And what is y? Square root of 7. You can think in this way here, based on substitution. Just think like this, don't keep on doing the substitution because it's very annoying, so many substitution there. So you just happen to have this mindset here to understand. Okay. Then we will go on. So for surd, there is nothing much on the rules. Let us go directly on simplify the expression. Simplify the expression. Again, I summarize the rules at the side here for us to refer, for us to apply. Okay. The first questions here is actually the questions that we talk about if I have the operation of plus minus for roots for surd. Okay, listen up carefully. If you have the operations of plus and minus among the square root, what you need to see is that you can only do the operation among the same surd. For example here, what are the surd that we have here? So we have square root of 5. We have square root of 7. So any operations of plus minus, you can only do among the square root that have the same type. Square root of 5 and square root of 5, square root of 7, square root of 7. So, how we solve this question as a result? Again, I copy back the whole thing, expression given in the questions. Then next, I'm going to group the same type of square root together to simplify. So for example, I group the square root of 5 together. So I will have 4 square root of 5 minus square root of 5. Then I group all the square root of 7 together. I have plus 3 square root of 7 plus 2 square root of 7. Then now I start to consider the operation. So 4 square root of 5 minus square root of 5, I will have the result here as 3 square root of 5. 3 square root of 7 plus 2 square root of 7, I have plus 5 square root of 7. That goes the answer. Okay. Once again, if let's say at this moment here, you are still blank, you don't know how is this plus minus can go on. Again, try to make use of substitution to help you. Let's say I have x equal to square root of 5. I have y equal to square root of 7. This whole thing here is actually 4x plus 3y minus x plus 2y. By right, you will see the logic, how I get the answer. 4x minus x, 3x. 3y plus 2y plus 5y. What is x and y? Square root of 5, square root of 7. That goes the answer. We try to visualize by substitution. But in your calculation, don't do substitution here because very annoying. Whether it's a simple question, you put a lot of substitution there, make it looks complicated. Okay. Go on. Next. Simplify this one. Okay, previously we do plus minus with the case that I can have similar square root to simplify, just plus and minus together. But now in these questions here, you see the operation we have is plus minus. And then the roots that we have, the surd that we have, is with different number. So how we can solve it? Of course, some of you will start using your calculator and press and get answer. Your calculator nowadays is very great to give direct answer. But in exam, if such question come out, you are not allowed to do so. And they will specifically say that without using calculator. So you must show some step there to show your knowledge, you know how to do step. Okay. So how are we going to start to solve this question here? So guys and girls, we're going to try to see each of these surd here. Is it possible that we can have them change to the same surd? So the clue is we're going to apply this idea here. The first formula here, but the other way around. The other way around. From one surd, we're going to break into two. We're going to break into two. And the breaking here, the breaking part here, please be aware. There is some skill that you need to know when the time you break it. So when the time you break it, right, you must make sure either one of the number here inside the square root, it must be a perfect square number. What I mean by perfect square number, for example, 4 is a perfect square number because 4 is 2 square. 9 is a perfect square number because 9 is 3 square. 16 square. 25, 5 square, so on and so forth. Must relate with perfect square number. I want to relate with perfect square number so that, for example, square root of a perfect square number like square root of 4, the answer I can simplify to become 2. We can simplify the perfect square number into integers or maybe fractions, depends what you have there. So this is why one of them, we must have it as perfect square number. So let's think about it. 8. Break it into two numbers, and one of them must be perfect square number. So I suppose 8, we can break it become 4 times 2. 32, 16 times 2. 18, 9 times 2. So how we solve it? Let's see. First line of the solution, I copy back the expression. Then now, based on the idea we see just now, 8 is 4 times 2. So square root of 8, I can break it to become square root of 4 times square root of 2 minus square root of 32 is square root of 16 times square root of 2 plus square root of 9 times square root of 2. Okay. Again, if you realize on the screen here, the typing is blue. The reason is because this step here for beginner explanation. In the future, you may skip this step here, where somehow some of you will realize that you're able to evaluate this value here fast enough and give direct answer. Where the first one is actually 2 square root of 2 minus 4 square root of 2 plus 3 square root of 3. Then we go for the calculation of the answer. So guys and girls, what we have for the result here, let's see. Now you have all of them happen to be the same roots. For operation plus and minus, I suppose you have 2 minus 4 plus 3, and I have the result as follows, square root of 2. In these calculations here, in blue, the step in blue here, I just do slowly the calculation according to the formula here, where I begin with, if let's say I factorize the square root of 2, so I have negative 2 square root of 2 to the next line, followed by plus square root of 3, plus 3 square root of 2. And then this one again, we repeat the process. We follow the formula here. We factorize out the square root, and then we simplify the answer. So the answer is square root of 2. Of course, once again, the blue step here is not compulsory step. After some time, I believe you master the skill, you can get this answer here without the blue step. Okay. Continue. Go on. Next, we want to talk about something about multiplications about indices. Sorry, multiplication about Surds. Okay. Let's say now I have two number here, evolve of Surds, square root. I multiply them. How I get my answer? Okay. I'm not sure last time in your SPM level or your lower form how you happen to learn expansion, but for now, in order for you to understand how I do the expansion, let me explain to you the idea that how I do the expansion. Okay. First of all, I will break the first bracket into two parts. The first bracket terms into two parts. The first part I highlighted in yellow, the number 1 in front. And then followed by the second part I highlighted in red, plus square root of 2. The second part and onwards, if there's more term, the second part and onwards, I need to consider the sign in front of it. If there is, of course there is a sign in front. I need to consider the sign in front. So when the time I expand, I need to consider this sign at the same time. So now watch out. Why I want to break it into two parts so that later in my calculation, I will take each of this part here, multiply the whole thing on the second bracket. I will break each of the part here, multiply on the second bracket. So how we solve it? Original expression given, we copy back. Then the next line is the one that I try to tell you. I will have the 1 multiply with the second brackets. Then I have it plus with the second part, square root of 2 multiply with the second bracket. And then we expand slowly. We have the answer. 1 multiply 3, it will be 3. 1 multiply negative square root of 2, negative square root of 2. Similarly, square root of 2 multiply 3, I will have 3 square root of 2. Square root of 2 multiply square root of 2, I suppose I have square root of 2 square. And please consider the sign, negative and also positive and negative, so I get negative. Reach up to here, again, you see the typing is in blue because after some times, maybe you're able to just observe the multiplication idea I show you in here and give me this direct answer where we have 3 minus square root of 2 plus 3 square root of 2, and then this square part here, you may able to give instant answer as negative 2. Then finally, we simplify our answer. We simplify among square root of 2. We simplify among the non-square root terms. And as a result, 3 minus 2, I have it as 1. Negative square root of 2 plus 3 square root of 2, I have the result 2 square root of 2. There goes the answer. So this is how we get the answer for question number 7 here. Okay, can I continue? Go on. Next. Am I going too fast? Is it okay? Okay. So go on. Next. Question 8, 9 and 10. Here I want to discuss about some important expansion. Why I say it's important expansion here is that I want you to learn. I want you to learn and apply your prior knowledge. I believe this expansion here you learned before in your lower form. If let's say I have m plus n squared, what will be happen to the result? What will happen to the result if let's say I have such situations? So guys and girls, let's see. Continue. Okay. So this formula, I don't want to explain too much. I just apply. So what I have is that if I have m plus n squared, the expansion, not only I have the m and n squared, I must consider there is plus 2mn as well. In your previous lower form, maybe you have this as the arrangement. You have this as the arrangement. But whenever dealing with the case with square root, I will go for such arrangement, the plus 2mn behind. So observe carefully how we do this expansion fast enough. You don't have to expand like just now what I do, slowly one term by one term, but we can just happens to have this done. Have this done easily to get the answer. So guys and girls, let's see. I copy back the original expression given. Okay, observe carefully. This is the m. This is the n. We have them plus together and we want it to be square. The result I should have is that, according to the formula here, m square, I should have it as m square, n square, plus together, plus 2 times of mn. So if m is equal to square root of 3, m square, I square the square root become 3. N is square root of 2. N square will be 2 itself. So as a result, what I will have here is that, let's see. Initial calculation, again in blue for reference, for explanation. M square plus n square plus 2 times of mn. Then the square part there, it will be 3 plus 2. The square root part here, apply rule number 1 on this. Square root 3, square root of 2. I will get the answer, multiply, and turn out to become 2 times of square root of 6. Simplify 3 plus 2, 5. There goes the answer. So by right, you can get the answer around in 2 or 3 lines only. You don't have to do too long expansion if you know that. Okay. Similarly, question number 9. Question number 9. I need to really know how to do this expansion, especially in terms of time solve equation to this. Okay. Go on. So now the similar case here. What is the formula we want to use? M minus n, and then the whole thing squared. M n. Your m is equal to 2, n is equal to square root of 6. Refer to this expansion formula given. So what is m squared? This is actually equal to 4. Or maybe we do it slowly. Result is m squared plus n squared minus 2mn. So we will have m squared is 2 squared, n squared is square root of 6 squared, minus 2 times of mn. Simplify the answer, we have 4 plus 6, and then in here, negative 2 multiply 2, I should have the answer as minus 4 square root of 6. Then 4 plus 6, 10. There goes the result. Okay, go on. Question number 10. Another important expansion that you need to know. This is about multiplication of conjugate pair, where the reference formula is this one here. I can have m plus n, m minus n, or the other way around. The result is m squared minus n squared. This is important, especially when the time you want to do rationalize, you want to do rationalizations. Rationalizations, when the time you want to multiply conjugate pairs. When the time you want to multiply conjugate pairs. So once again, we are not going to expand slowly like just now one by one terms, but we're just going to apply this result if I have such formation. So let's see how we do for this question here. Let's check. we have 3, 3. Square root of 2, square root of 2. One is plus, one is minus. So how are we going to solve for this question here? Let's see, guys and girls. M plus n, m, n, m minus n. So m is equal to 3, n is square root of 2. So if apply this formula, what I have m square minus n square. What is m square? So 3 square is actually 9. Square root of 2 square is actually 2. So it's just as simple as 9 minus 2. Then answer 7. Again, it's two-line answer. I need you to really know this idea here so that when the time do rationalization involving conjugate pair multiplication, you can do it fast and efficient. Okay. Clear? Okay, I go on. Next, I want to discuss about rationalization and simplification. Okay. First of all, talk about the word rationalization. What is rationalization? Just in the simple word to say that if let's say you have a fraction term, something over something. The idea of rationalization is that at this denominator part here, we don't want to see any square root. We don't want to see any square root. Of course, when the time I say I don't want to see any square root, we're going to make it achieve mathematically. Not to say that I don't want to see square root, then you close my eyes so that I don't see the square root, or you erase the square root. But we're trying to get rid of it mathematically. So in here, rationalizations, we have two types of basic situations that we're going to discuss in today's class here. The first situation here is the simple case where, in this case here, we have the denominator consists of only a square root term. It doesn't have plus minus with another terms. So if just only have square root terms, how we get rid of this square root here mathematically is that this is what we're going to do. We're going to have this term copy back, and we have this term here multiply with the square root top and bottom in this way here. And for information, how come this thing just suddenly appear can be multiplied and then it's valid for answer? The reason is because this value here is actually equal to 1. You're actually multiplying 1 so that before and after the value is the same. But of course, if multiply 1 in this form here, it will look a bit stupid, because not only the value is the same, the form is the same. You're still stuck in the form. So therefore, in order to have the same value but different form, we also modified this one here to some other form. For example, here we modify in the form of square root of 2 over square root of 2. Where we get this square root of 2? Based on the denominator. And this multiplication, in your notes, maybe it will just say, you see square root at the bottom, only square root at the bottom, then we multiply the square root itself. So actually, it's the one in square root form like this, it means. Then now, continue. What I have now is that on top, 6 multiplied square root of 2. Bottom, square root of 2 square. Again, this typing in blue, because this step can be skipped. As after some time, you see square root 2 multiply square root 2, you can instantly tell that it's just equal to 2. And this fraction here, we can simplify, become 3 square root of 2. End of the story. So this is the simple case. We can just rationalize easily by multiplying just the square root terms itself. What if now I have the much more complicated case where not only consists of square root, but it's plus or minus with some other number or some other square root? How are we going to solve that? So in this case here, we need to take notes on the knowledge on conjugate. What is conjugate? So guys and girls, just in a very simple way, but not totally correct. Just in a very simple way for you to remember conjugate is that as if let's say these are the term involved, you take the sign in the middle, you change it. Negative, change to positive, conjugate. Positive, change to negative, conjugate. It is two-way. It is two-way. So this is a simple way for you to remember about the idea of conjugate. But maybe not 100% correct lah, because I doesn't explain in a professional way on this. Just by observation, this is the rough idea we can see for conjugate. Go on. So now, how to rationalize this? By using the conjugate. So this is the original expression we have. This is equal to, we have this expression here, multiply with 1. So that before and after, they are equal. But once again, if multiply 1 in this form here, later the result come out is still in this form here. You still stuck forever. So we're going to multiply the 1 here is in the form of the conjugate of the denominator. In the form of the conjugate of the denominator. So 3 plus square root of 2, the conjugate will be 3 minus square root of 2. And top and bottom here, this part here, is the same term because this is actually equal to 1. So remember, top and bottom is the same term for the multiply conjugate because you're actually multiplying 1, but in conjugate form here. So as a result, this is what I have initially. If these two terms multiply, this is the result. And observe, I do have bracket for the first pair on each of the numerator and denominator. Must have bracket there. If you know bracket right, you write like this only. For example, you write like this only. This is wrong because this means that only square root multiply the bracket. But what you want actually is the whole thing, 1 plus square root. So you need to have bracket. And then now, what we're going to do is that we're going to expand our answer here. Okay, for this one, right, I will just quickly erase the answer for you to see only because if you happen to realize this multiplication, let's see before one. This multiplication also, like you see before one, because it's the previous example. It's the previous example. So I don't explain much. I just go directly for the answer. And by right, you simplify, you got this as the result. Again, these two is actually what you can see in the previous expansion. This two is actually from the previous expansion you can see. Okay. So I'm not going to repeat. If you like don't know what I'm saying, okay, I show you. This one we just done. The denominator is this one. The multiplication is this one. Then the numerators, the multiplication is this one. I have done the multiplication just now. That's why here I just go on skip explanations. I just go for the answer because it's already done. It's already explained previously. Reach out to here, guys and girls. The final answer usually we want to keep in the form of like this. One part with square root, one part without square root. So how are we going to do that? We're going to split it in this way here. According to the color, 1/5. And then the other one, 2 square root of 2/5. And the operation between them is plus. Then this is the final answer that we want. Finish. Okay. So, any problem? Did I make any mistake in the calculation here? Oh, yeah. Thank you. There's no miscalculation here. Suppose here is 2 only. Because this one supposed to be 2 only. And therefore, the answer here is 7. 7. Please check back. Did I make the same mistake previously in the calculation? No. So, copy pun salah lah saya. So, this is the answer it's supposed to be. Thank you. So, I hope that from here you can see lah, you don't just copy only. After this, you please read back the calculation, try to redo. Who knows, I didn't realize that I made mistake in the calculation here. Okay. Lastly, solving Surd equations. Okay, guys and girls. In here, I choose two very simple example. But originally, these questions here may not look simple, but I somehow make it look simple and directly solve. Like just now, the indices equation. Originally, I can make it look complicated, and then you need to do some adjustment before achieve this form here. So let's see question number 13. We have the case of square root of x plus 1 equal to x minus 5. This is the question that we have, that those of you have entered lecture. This type of question, the strategy to solve, I believe, you remember is square both sides. But what is the term and condition to square both sides? Maybe you ignore that because you already have the form get ready. What if you doesn't have the form get ready? You need to do something. Then what you need to achieve before squaring both sides? This is what you need to consider. Okay, refer to this other form here. Again, the same question here. The question looks so simple here. I can actually increase the difficulty like this one. I rearrange the term, I simply put the term, but after you rearrange, they are the same. The second one, not just only rearrange, but I happens to, this one, compare with the original equation is that the left hand side I plus 2x, the right hand side I plus 2x. But after you rearrange and simplify, same equation. Okay. Watch out, the last one. The last one masih sama ke? There is 2 square root there. There's 2 square root there. How come a 2 square root question and 1 square root question they are equivalent? So guys and girls, if you observe carefully, these 2 square root is the same square root. They have the same content. If you try to simplify, right, this 2 square root from 2 square root minus square root, I will just get 1 square root. Simplify these two I highlighted in yellow. Again, you come back to this equation. So the original equations, before achieve this example, it can have multiple of form. But again, in our lecture here, I just want to focus on the skill first. The changes before that, maybe you will see when the time you do practice in some exercise or past year question. In here, I just need to warn you lah, don't just blindly squaring both sides. What is the condition you need to have before you squaring both sides? Okay, let's see. In this case here, this is the case that we have only 1 square root. The formation that we need for solving 1 square root is that you must try to arrange the equation in such that only one side consists of square root, the other side without square root. Then only you start to consider squaring both sides. Of course, this question, formation is ready. So that's why we just square both sides. If I happen to give you other form like this, please have some efforts to achieve this one first, then only we square both sides. And another thing, it is not necessary the square root must be on the left. It can be the other way around. That means it can be having x minus 5 on the left, square root on the right. Like this also can. As long as square root one side, the rest on the other side. Then only we start to consider squaring both sides. Okay, observe. Copy back the original equation. Next, what we do is that, I believe most of you, after writing the first line of this equation, you are so excited to square both sides by overlapping this equation like what I'm doing now, and then you get the result as follows. Then we expand and get this result and check this expansion here, you don't have to write down x minus 5, and then you expand slowly to get answer. Because, again, refer back to the important expansion formula I showed you just now. The only difference with this arrangement here is that once again, I happen to have the 2 minus mn. Sometimes I put in the middle, sometimes I put at the back. That's it. But they're actually the same thing. You can try to see if I follow this formula, I should have x squared plus 5 squared minus 2 times of x and also 5. So as a result, this is actually minus 10x. So they are the same thing actually. Go on. Next, what we want to do now is that we want to solve this quadratic equation. It's a quadratic equation, again a quadratic equations. So rearrange, I would like to group all the terms to the left. So this is the answer that I have initially. Okay, watch out guys and girls. I believe nowadays you will totally depend on your calculator if I ask you to do factorization. And I would like you to take notes. The result you have in calculator is not factorization. The result you have from your calculator is actually from these equations, it go directly to the answer of the equation. That means your calculator is actually show you this final answer 3 and 8. And then after you get this answer here, you as if like you try to cheat me, you convert back into factor form. And when time you're doing this, guys and girls, please be aware. You must make sure this equation here and the quadratic equation you have is tally to each other. What I mean by tally to each other is that when the time you expand the factorization, for example, you multiply the x, the result of this multiplication should be the same as the quadratic equation I have. Where I multiply x and x, I get x squared. But what happened in your equation here? Negative x squared. So if from here you say that you factorize get this is a wrong factorization. So in order to get the correct factorization, be aware what are the things that you need to take care. First, you check each of the term, the square, the x, and also the constant. Do we have common factor? If common factor, divide the common factor. Second, you need to check the power 2 terms. Do it come with negative coefficient? If there's negative coefficient, please kindly multiply with negative 1 to make it to become positive. Or you can divide with negative 1 to make it positive. Not just divide this term, divide all the term I highlight in red just now. So for example, in this case here, yes, I do have the case that I have negative x squared. So what I do now is that each of this term I underline in green here, I'm going to multiply with negative 1. So I will have the result as follow now, where I have negative x squared become positive x squared, plus 11x become negative 11x, negative 24 become plus 24. Okay. Then go on, reach up to here, you have two answers, x equals to 3, x equals to 8 after you solve it. Okay. Continue. Pay attention. I believe after some time, when the time you do calculation like this, how you decide the final answer for Surds, you may have some biased thinking in such that you look at the answer here. Whenever you see negative, I believe you without hesitation, you reject the negative. Or you see it's fraction, you reject fraction. You only want to accept the answer is positive and it is integer. Because usually answer is look nice like that. But that is not true. How you choose the answer is not based on the looks, but it based on the mathematical concept. So in here, what I want you to do to decide the answer is that we try to refer back to the original equations. We try to refer back to the original equations. This one, the original equation. The left-hand side, the part I highlighted in green. The right-hand side, I highlighted in red. Then we try to substitute. The x value that we have to each of the left and right hand side, and we try to see, do they give the same answer or not? In here, I already calculate the answer for you. So, and if I substitute 3 inside for the one in green, I get 2. Substitute to the one in red, I get negative 2. So these two are not equal. 3 is not the answer. But again, don't have misconception to think that this is not answered, must be the other one is answer. Not like that also. You must check also. Who knows both of them is not answer? Or both of them is answer. So substitute 8 inside, we get 3 equal. So 8 is the answer, and you need to tell your decision, you reject the one that is not answered. Or you don't like the word reject, ignore, omit. So these are the words that we can accept in the decisions. Okay. Continue. Okay. Okay. Last 10 minutes before we reach to 4 o'clock. Okay. So let me finish the last questions. Okay. Last questions. Question number 14. This question is the important form of square root equation where if in exam, if let's say exam want to come up question about square root equation, they are most likely to come up this question here. You can try to check your past year, your tutorial book, the past year question part. Out of five square root equation, four of them is the case something like this, where I have the case of two square root, two different square root, I should say, two different square root. So this is the one that is most popular to come out if let's say they want to come up square root equation. Okay. So again, maybe in lecture you just directly square both sides to solve. But once again, you need to know what is the best formation before you square both sides. Not to say in other formation cannot be solved, but we want to have the best formation before we square both sides. Okay. So the best formation is that we want to have square root 1 on each side. We don't want to have square root on both sides, whether it's plus or minus like this. We don't want this formation. Not to say this formation wrong, but just that later you square both sides, you expand, it will take times to multiply. So therefore, we avoid have two square root on the same side like this. We try to make one on each side. Okay. Similarly, I say just now, this question here, I already arranged it nicely to you and get ready, direct square both sides to solve. But the actual fact in the questions here, you can have some other form. For example, the first one, you need to arrange before you square both sides. The rest of the one below right actually can be squared directly also. It's just that I try to tell you that the same question, I can have different form of arrangement, but yet they are the same questions. Okay. Now, continue. Start with, copy back the questions. We copy back the questions. So we copy back the equation given. Then what we do the next is that we go to square both sides. Guys and girls, pay attention on the square both side here. This is the part that a lot of students make mistake. So we square both sides, we square both sides. For this one on the left, no problem. It will just simplify, become x plus 1. But for the one on the right, always have students have misconception. They think that the square, they just expand inside, become 3 square minus x minus 2 like this, which is wrong. And what we're supposed to do in this expansion here, guys and girls, again, we refer to this expansion formula. Refer to the part I said important expansions. So once again, I will consider this m minus n, and then bracket square m n. So the m is equals to 3, n equals to square root of x minus 2. Okay. So now we do our expansion. In this expansion here, I may not write as detailed as just now. So some of the important fact, I will just do it directly here. So in here, what I will have is that, okay, continue. If I happen to expand, I need to know what is m squared. M squared is 3 squared, which is 9. What is n squared? Square this one, I will have it as x minus 2. So as a result, the left hand side maintain the same. The right hand side, watch out, start with m squared, where m squared is I take 3 squared, I will have it as 9, plus with, according to formula is plus, the minus is considered when time the 2mn. Okay. Plus with n squared. N squared is x plus 2. I purposely put the bracket to you for you to see clearly that this is the whole thing about n squared. Then minus 2 times of the m and n. So minus 2 times m and n. So you can see the expansion can be done faster and easily. Of course, for some of you, it's at once enough. Maybe this part here, you will just directly put it as 6. But today, I just do it slowly. Then next, what we do now is that, let us proceed further to simplify the square root part. To simplify the part without square root, this part I highlighted in green. So I have x plus 1 is still remain the same on the left. Simplify the part I highlighted in green. I suppose I have x plus 7. 9 minus 2 is 7. Then plus with x. The one highlighted in blue, what I will have now is that you see, I have minus 6 square root of x minus 2. Okay. Reach up to here. Now, in this line here, what you can see is that you will see that this is actually back to the case of 1 square root. 1 square root, what is the best formation we need is square root one side, the rest on the other. And try to make it in such that we don't want to have negative in front of the square root. So in this part here, I would like to reorganize in the way that I would like the square root reorganize, arrange it to the left. So as a result, it becomes plus 6 square root of x minus 2. If the square root have moved to the left, then the x plus 1 will organize, move it to the other side, and by the time you simplify, you find out that x moved to the other side, it will become x minus x, 7 minus 1, answer equal to 6. Okay. So now you simplify into this form here. Square root one side, the rest on the other. This question, you are lucky enough, the x totally gone for non-square root part. It will turn much easier. Then reach up to here, guys and girls. Another important thing on this part here, whenever you have the case of 1 square root, if there is a number outside the square root, before you're so excited to square the second time, try to check, can we reduce this number? Reduce in the sense of, instead of having squaring 6, can we square a smaller number by reducing it? So how we do that? We try to check, do I have a common factors on 6 on the other side? And obviously I have. So I will divide the common factor, divide with 6. So I have square root of x minus 2 equal to 1. Squaring both sides. Okay, this is simple squaring both sides. So I'm not going to write the bracket square lah. I just get x minus 2 equal to 1. Answer, x equal to 3. So reach x equal to 3. I believe majority of you left one answer only. So this one must be the answer. If not, we choose who? It can't be this one also we reject. So yeah, by right it is like that lah. But let us try to do the verification. Sorry, I think this verification is a wrong verification. You need to copy back. The printed notes, I give the wrong verifications here. So just have a quick verifications. Let me write down the verifications. So how we have the verification done? Refer to the original equation, the original equation in the questions, which is this one, now I highlighted in red. The left-hand side of the equation is square root of x plus 1. The right-hand side is 3 minus square root of x minus 2. The x value we have is 3. Try to plug in 3 inside. I find out that this result here, I have it equals to 2. Plug in here, I also get equal to 2. They are the same. Therefore, yes, confirm, x is the answer. So this is the result by verifying the answer. Once again, the answer that is printed for the verification here is wrong. I copy-paste wrongly after I do the calculation. So please make sure you take notes about that. Do correction on this part here for the verification. Okay. So basically, that's all for our lecture here today. I don't think it can really help you to answer all the questions 100%, but I hope that at least it gives you some new ideas or it help you to understand a bit on these two chapters here. So therefore, I will end my lecture here and I will end the recording here. Thank you very much.